Well, I think there may be a problem straight away. I came to learn about cobalt, so maybe I'll make my presentation quite short. But no, thank you, Alan. It's great to be back here again. We don't often get the opportunity to travel halfway around the world, but we also had our own Cobalt Institute conference in Hong Kong, so it was a logical step to drop down here and support Alan. So what I want to do is give you an outline of what we do on the Cobalt Institute side. All you people in here are very used to getting things out of the ground. Our remit is to look at protecting market access because, believe me, there's a whole range of pressures to try and design out anything that potentially may be hazardous in this world today. And if we can't get our metals and minerals designed into modern products, then there's not much point in you guys digging a hole. So that's what keeps us awake on a regular basis. Quick note from my lawyers to say you can't rely on anything at all that I say here, which is great. But on a more serious note, there is a limitation to what I can actually talk about with regard to because of antitrust. So, just a quick overview. I want to look at a quick look at the Institute to show who we are, what we do, look at some of the historical changes in the cobalt market because I've seen quite a lot over the last almost 40 years. Obviously, the biggest impact is going to be from the upsurge in lithium-ion battery technology. We need to look at some of the critical issues such as responsible sourcing, which I'm sure you're all aware of, look at the sustainability side of cobalt, and also look at the global regulatory perspective, which is because cobalt is under an awful lot of scrutiny in an awful lot of areas globally. So, who are we? Well, we are the Cobalt Institute. We used to be the Cobalt Development Institute, for those who remember us. The company itself, the organisation itself, has been going for over 60 years. We became the Cobalt Development Institute in '81, and we recently renamed ourselves the Cobalt Institute because we don't actually do any development work. It's far too specialised. So we're a non-profit organisation, and our whole remit is to promote the sustainable and responsible sourcing of cobalt in all its forms and act as a knowledge centre for a whole range of stakeholders such as governments, academia and industry as well, and we focus largely on regulatory and global policy developments. And this more or less sums up what we do. We do all the cutting edge science with regard to human health toxicology, environmental toxicology, and how that applies to chemical management. So that is our regulatory theme. Very large proportion of what we do, probably 60% of our resource and up to 80% depending on what we have to do goes into regulatory requirements. We're developing the sustainability profile for cobalt. As you'll see, that's terribly important because globally regulators, legislators look at the whole life cycle of metals and minerals, not just cobalt. And also responsible sourcing becoming more and more important. It's an issue which we've spent a lot of time and effort on because there's a perception, certainly for cobalt, that cobalt is produced by children scratching around in the earth, and this is something we have to try and show is not the case. And then we have to advocate our positions, both technical positions and our overall, communicate the overall position for cobalt, again, to try and protect market access for cobalt. And I'll develop those themes as we go on. So that's us. We have some 19 full members who you'll recognise from there, and we have some 15 associate members of the Institute. But we probably cover about 70% of the world's cobalt units that are produced. So let's look at the cobalt market in a bit more detail. And certainly from, I'm sure you all know that cobalt was very much known as the blue pigment going back some 3,000 or 4,000 years. But it was really towards the end of the 1800s when some commercial uses started to be picked up for cobalt, particularly as you see from the graph here, as it was a bonding agent for glass and metal, and then some catalyst applications started to be developed. And it started to become more mainstream, if you can call it that, because it was a very small volume in those days, when Elwood Hayes started to patent some very special alloys, and these special alloys came to be what we now know as superalloys. This is obviously in the 1910s, 11s, 12s, that was rather basic alloys, but essentially driven by the need for more high-performance engines and also alloys which were able to withstand higher temperatures. And then in the 20s, along came the development of tungsten carbide hard metals that contain cobalt with Karl Schroeder. And then with those sorts of developments, we start to see the development of more modern materials, more high performance materials, and so on. And then into the 70s, with that traditional industry behind us, largely metallurgically based, we then move into the development of lithium cobalt ion batteries. And I've put down 1979 here when they first were designed, but I did meet Stanley Whittingham a little while ago, who developed the lithium-ion batteries, and he tells me it was 1974. So that's a little bit wrong, but I got it from the horse's mouth, which is rather good. And then the market's changed quite considerably by the turn of the next century, as we started to see the development of the lithium-ion based system. But of course, we all had portable phones, portable devices. These devices are now intrinsic. We have to have them. I don't know about you, but I cannot do without my phone. And the movement now to the energy transition to electric mobility is a fundamental and paradigm shift in the fortunes for cobalt and indeed other energy metals as well. And the way I like to think about it, when you actually analyse it, the change from horse-drawn carriages to the internal combustion engine, I think the paradigm shift from the internal combustion engine to the battery-powered electric cars will be equally as dramatic in terms of our industry. So a quick look at the overall market going back for many, many years. It has been characterized by being a volatile element, both in terms of price and in terms of availability. So you can see I've put a whole range of aspects which did affect the price over years. Most particularly because DRC, or Zaire as it was, has always been the major supplier of cobalt to the market. And of course, there's been significant instability in that area over the years, notwithstanding, I remember the Komoto mine collapse and indeed the civil unrest in the area. But nonetheless, it's still producing, and the market has still remained volatile. Why? Well, it's very illiquid. It's a very small market. I mean, up until recently, around about 100,000 tonnes or less. And that's only in the last 5 years that it's got to that level. So you can see the market can be pretty well affected. This is relatively smoothed out because I've taken the Metal Bulletin quarterly average. But you can see up until the financial crisis in '78, there were various things affecting the market. And then we hit a period of very, well, let's say stability, which I call the calm before the storm, because you can see that certainly by 2017, 2018, the market returned to its normal form, and there we have a huge peak, and then the market fell off a cliff again. Possibly because the market just got over ambitious with regard to where cobalt was in the current trend. And here we have the old cobalt market, the one I grew up with. It speaks for itself in terms of the segments, but really about 70% of cobalt used to be used in metallurgical applications and around about 30% used in chemical applications. But the majority of the largest use, of course, was superalloys, hard metals, magnets, and so on. Magnets there at 11%. Actually, the magnets was a much bigger market in the early 80s, but we lost out to the ceramic magnets over the time, not really because of price or anything else, but the ceramic magnets were much easier to manufacture and cheaper to manufacture as well. Then we move to the modern world. Well, you can see it's completely turned on its head. The old market's still there, but we've now got batteries that have come in to dwarf the rest of the sectors. So we've swapped around completely now. Roughly 70% of the market is for chemical applications, and around about 30%, or give or take, for metallurgical applications. The old sectors are all still there. They're all still growing, but the market has been completely dwarfed by the rapid demand in the last 10 years from the development of rechargeable batteries. So big change over the years, certainly from what I grew up with. And here's just a map. This is maps available from the Institute if you like. You can just go online and buy it. We only sell it at cost. We're a non-profit organisation, but this is to help you understand the cobalt market. You can't read it on there, but it shows you all the main producers, the main refiners, and some of the selected projects which we think will come on stream. But once you start digging into that sort of detail, you can get onto this, which is a bit more informative. This starts looking at the mass flows. So we can start looking at the copper side of things here. As you know, most cobalt is obtained from copper, and then after that it's obtained from the nickel operations, and this shows you how it flows straight through to the various refining stages into the various end products. So most cobalt comes from copper, a significant amount from nickel operations around the world. Primary copper is still really only the CTT operation in Bouazer in Morocco. There's some cobalt associated with PGM, some from, we put unknown sources, but that really we're perhaps talking about artisanal small-scale mining, and indeed then, of course, secondary sources. But this is available from the Institute if you'd like to buy it. As I said, it's only a modest cost, and we sell it at cost price. Little bit of detail on there, but this really just to show you that the most important refiner of cobalt in the world, if you didn't know, is China. They refine, they import the most cobaltiferous raw materials. They make the largest amount of battery precursor materials. They make the most batteries, and they make the most electric cars. So they are dominating the industry at the moment. And where does it come from? Well, here's a map of the reserves, which I'm sure you may well have seen. We take this from the USGS statistics, and DRC is way out there in terms of reserves, followed closely, or not even closely actually, but followed by Australia, and very modest resources thereafter. And then in terms of production, we'll go back one slide there, because one thing that isn't taken into account currently is the potential for deep sea manganese nodule mining. That's becoming a little more overt now. There are a number of companies that are looking at mining the seabed, so there's a possibility there. Of course, we may see that in the next few years, particularly as we see the demand ramping up for cobalt in rechargeable batteries for cars. And then biggest producer, well, surprise, surprise, it's DRC, and I don't think that's going to change much. It's a country mile ahead of any other country, and indeed has the ability to turn the wick up and down as it so wishes. Either it can self-destruct or it can do it constructively, but it has the capacity to meet current demand. This is an old graph, so you don't necessarily need to take too much notice of this. There's a limit to what I can do in terms of trying to be upfront and cutting edge with these things. But this is just to demonstrate really that we are anticipating significant demand for cobalt as a result of electric mobility. And in fact, I beg your pardon. What we can notice here, around about 2018, we know the market has somewhat softened, so that actually has come into a bit of a surplus there. But that doesn't detract from the fact that certainly by 2025 or 2030, we could see a doubling or even tripling of the demand for the cobalt market, and one way or the other, that slack has got to be made up. So the challenge is now really for the lithium-ion batteries. Well, not the batteries market as a whole, let's say. If you don't know, I'm sure you do, but cobalt, it's very unlikely that anything you have or any modern material hasn't had cobalt in its process or actually contains cobalt. This is just a small sample of what cobalt is actually used for and used in. It's never used on its own. It's not obvious like copper or aluminium or stainless steel. You won't see it. It'll be used in conjunction with something else, in an alloy, in a catalyst, in a chemical reaction, and so on. But it has a very, very broad range of uses, a number of which are absolutely essential, certainly in catalysis, where cobalt is certainly needed. You can use something else, for example, but you will not get the process efficiencies that you need. And in health, for example, not many people realize that vitamin B12 is essential for growth and vitality in living cells or living and human beings. And if the pharmaceutical industry is not able to obtain a small amount of cobalt, it's certainly not, it's really only tons globally, but they're then not able to provide diagnostics, they're not able to provide vaccines, therefore you don't have a pharmaceutical industry. So that's just how important cobalt is. It is very important to modern materials and modern industry. So with regard to rechargeable batteries, the main raw materials can be in different forms of metal or sulfate oxide or hydroxide, and that's normally converted to lithiated cathode material. And there's some, let's say, between 55 and 60,000 tons of cobalt a year go into that system. There are new chemical systems. You probably read an awful lot about the different chemical systems that can be used. and indeed, who knows what the future holds. But right now, for the foreseeable future, which is very unusual for the cobalt market, because back in the good old, bad old days, we used to hope that the cobalt price would be better than next year. But now we can actually see a good 10 years ahead. I'm being very conservative in that view, a good 10 years ahead with regard to a long-term demand as we move into the electric mobility. And a lot of talk about the batteries as well. The batteries we normally have in our portable equipment tend to be the LCO, the lithium cobalt oxide materials. Tesla have followed the NCA, nickel cobalt aluminium type batteries. The most popular batteries thereafter are the NCM, nickel cobalt manganese type batteries. Lots of different chemical mixtures you can have in there. A lot of talk about 811 because that minimizes the amount of cobalt, so it protects a lot more for price and weight in the battery. That's probably not quite so important now the price is more moderate. There's not quite such an incentive to change, but if the price does become volatile, very high, one may see those types of batteries moving in. The 532, which are the percentages of the main materials, 532 or 622, those are the most popular batteries for the electric vehicles at the moment. And the main thing to take away here is that the car companies themselves they're gearing up and they're designing for cars that contain lithium-ion batteries. Superalloys, I mentioned this before. Most of you, I'm sure, are metallurgists, but the superalloy is a very important market for cobalt, and it's used largely in the hot ends, aggressive end of the gas turbine, because that's where the most corrosion is, that's where the most fatigue is, largely in static applications because of its properties. But that's the second biggest section for cobalt. Then we have the hard metals, as I mentioned before. Hard metals, so that's hard-facing tools, high-speed steels for cutting, grinding, and you can't have a manufacturing industry without these tools. So it's a very important sector, for both industry and also for cobalt. Are there alternatives in development? Yes, there have been, but cobalt still delivers the goods. Still, cobalt provides materials which cut very efficiently and last a long time. And then catalysis. Rather understated, but it's used in various forms, certainly in the textiles industry. As purified terephthalic acid, it's used in the molding plastics as unsaturated polyester resin. And perhaps more particularly, it's also used in clean fuels. A ton of cobalt can extract 25,000 tons of sulfur before it needs to be regenerated. So if you talk to the catalyst manufacturers, they say they call it the Goldilocks principle. They have catalysts which do the job, and cobalt is just right for that job. And they will tell you if without something like cobalt, then we'll end up back with the acid rains we had back in the 70s, or 60s, 70s, and 80s. Also, as a catalyst in the gas-to-liquid technology, it's also very important. Gas-to-liquid, I think, is more variable with regard to price. So as we get a higher oil price, we would perhaps have more attraction towards gas-to-liquid. But nonetheless, there's quite a significant amount of cobalt that goes into the catalyst market. A lot of recycling there. Most catalysts are recharged. Also pigments, that's one of the traditional areas of use for cobalt. Still buoyant, and certainly as the Chinese market built up, that gave it a new lease of life. Remaining significant applications, magnets still very important. On the organic side, in terms of dryers for paints, also rubber adhesion. It's intrinsic for safety in steel-braced radial tires, for example, and other uses would be in coatings, medical prosthetics, ICT. I talked about ICT. You wouldn't know how much this tiny amount goes in there, but it's essential. Pharmaceuticals, prosthetics, and a whole range of other products as well. So responsible sourcing. I'll move on to the other areas really now of sustainability. Responsible sourcing, very, very big issue. It's one of perception. If you go outside this room and I bump into a member of the public, first they'll ask what I do, and I say I work in cobalt. They say, what's cobalt? And then they'll say, that's mined by children, isn't it? And that's the perception of outside this room, outside the industry. That's what people think. So a lot of time, a lot of effort to change this message, because that's not the case. Largely through pressure from international civil society. You've seen a lot of articles by people like Amnesty International. Also regulatory pressure, the Dodd-Frank Act, also the European conflict minerals legislation. Most of our members are large-scale miners, and that cobalt is a byproduct from those operations. So we have developed the Cobalt Industry Responsible Assessment Framework to deal with this. What this does, it allows you to assess and mitigate the risks you have for your sourcing or your production, and it also allows a more coherent and consistent approach to due diligence and also by formal reporting. So it's a management tool which allows participants to prove they are aligned with global good practice, and that's the main thing, and they must do that transparently. The areas that we particularly cover, we have 4 risk categories: environment, occupational health and safety, human rights, and community engagement. And we have 9 other risk areas, which I think you can pretty well read from there. The key element is human rights. We need to be able to demonstrate very clearly that there's no conflict and corruption within the process, and that human rights are respected. And we do that in accordance with the OECD Annex 2 model, which, when you've got a quiet moment, please do read. It is important. And also child labour. Of course, child labour does not feature into our members' work categories, because that's forbidden in any case. But nonetheless, we have to demonstrate that. And also community engagement. We need to be able to provide alternative livelihoods, protect existing livelihoods, look after resettlement, because that often happens in the mining industry, and also trace somehow the artisanal and small-scale mining activity, which is really what this is all aimed at. Not necessarily the large-scale mining industry, but we have to demonstrate we're being responsible. We have 3 different areas to move into in terms of the CIRAF, for example. This is the entry level which you must come in at, and that actually recognises human rights, but you also have to have evidence of your risk-specific policy, and you must publish that risk. There must be evidence that you are adhering to, for example, the OECD due diligence guidance. And then there are different levels you can go up to, 3 material risk areas here, or all risk areas there. But the key thing is there always needs to be evidence of your specific policy, there needs to be evidence of the management system, there needs to be evidence of public reporting, and that's what the NGOs want to see. They gave a muted response to our Cobalt Industry Responsible Assessment Framework, but that in itself is quite a result. But they expect to see the reporting. So that's one part of sustainability. The more empirical sustainability here is the circular economy. I'm sure a number of you will have heard of, or all of you should have heard of by now, I would think. And this aims to measure every single part of the supply chain, so that what you have is a material that goes into your products which is sustainable. And this is going to get tougher and tougher and tougher, because the regulators, legislators are going to try and measure more and more elements of each segment of the economy. So from a raw material perspective, what we need to know is how sustainable that is. So you need your life cycle, you need that measures your global warming potential, your eutrophication, your water use, your land use, and your environmental impact, all those sorts of things. But also, more and more, it'll start looking at things like the Global Reporting Initiative. It'll start looking at EITI, the Extractive Industry Transparency Initiative. It'll look at all those elements more towards corruption and the like, so that raw materials going into the supply chain are sustainable. Once they're in the supply chain, then there's a big push now to look at product design. Each product needs to be designed, or it's called eco-smart, so that it can be designed for minimal, or let's say maximum service time, that it's reused, it can be re-engineered and so on, until eventually it gets towards the end of its life. So that when things get to the end of their life, there's a minimum amount of material into actual waste itself. So a very important part. So we'll be looking very heavily at recycling. For cobalt, what that'll mean is we need collection points for the batteries. We need systems and technology that's going to rip the batteries apart and then bring the material into a form that it can easily be extracted. There are a number of different extraction processes. All look very efficient. At the moment, there's not one specific process that is being used. But nonetheless, the recycling element will be extremely important because, as I said earlier on, we're looking at a doubling, maybe tripling of the demand for cobalt. There's a limit to how much the current market can supply, so recycling will be a very important element in making sure that's a sustainable growth. So the circular economy and the whole life cycle, very important, and the Institute is developing the measure of cobalt in that supply chain. So we're developing all these markers. We've done like the industry life cycle assessment, we're doing a socioeconomic report, we're doing mass flow work so we can understand where cobalt fits in the overall scheme of things. And then we look at the global regulatory perspective. This has dominated what we've done for the last 10, 12 years. And it is very tough. Probably up to 80% of our resources had to go into this. Principally the REACH regulation in the EU, and the REACH regulation in the EU is the most comprehensive chemical management system anywhere. And what it has identified has meant that everyone has had to do, and many have already done their risk assessment. Cobalt, we're a little bit behind the curve there, but nonetheless, we've had to produce, like everybody else, a dossier on cobalt, which gives it all its characteristics. But it also gives the classification as well. As you probably know, the cobalt salts are already globally classified as carcinogen, mutagen, reprotoxin. That we knew, but they've also been put on the substance of very high concern list in Europe, and now they're being restricted in their use. So we're working through a public consultation, providing a lot of information with regard to the characteristics of cobalt and why it shouldn't be restricted. We're not sure what that restriction will look like at the moment, but what we are actually trying to do is look at having a binding occupational exposure level, which is much easier for industry to be able to adhere to and much more logical than just having a restriction on the cobalt salts. Another very important development is for metal is the CLH, which I put up there. That actually just means a harmonized classification under the GHS system, which is all routes of exposure, which we don't agree with as the Institute, or indeed the industry, because there is only evidence that there's a potential for cancer through inhalation. But by the nature of the way the REACH regulation is set, then they just simply adopted the other routes of exposure as well. So that we're pushing against at the moment with as much science as we can. The difficulty we've got with the harmonized classification is that they want to put in a specific concentration limit of 0.01% for cobalt. Now, if they maintain that pressure, and thankfully we've actually got a stay of execution because we've asked them to redo the methodology because it's not scientifically derived. But if they maintain that position, 0.01% will mean that all stainless steel will be potentially carcinogenic, which means you can't recycle it. So I don't think there's a great deal of thought that's actually gone into this, and there's no reason to have a 0.01% specific concentration limit for cobalt, but you can see the damage that could do to the industry. What do you do with prosthetic implants? What do you do with touching this stainless steel here? It makes it extremely difficult to know what the regulators want, and they really ought to talk to each other because they've got another side, let's say their DG enterprise or their enterprise zones, pushing for chemicals, pushing for new materials, and yet on the other side, let's say the European Chemical Agency is looking to try and banish any hazardous material within Europe. So that's the position that we're stuck in. And because of that, the other cobalt compounds are being looked at in what's called the Registry of Hazardous Substances under electronics and electrical areas. Now, we don't have any cobalt substances in electronic or electrical items, but they do use cobalt in the process to get some of those items. So we're going to do a lot of work there, and we don't really know why we're being considered, but there we are. And also, because of everything happening over here, there's a big chance that a lot more cobalt compounds will get drawn into the argument as well. And that takes up a lot of effort, a lot of time, a lot of money. We've spent maybe 25 million euros on implementing REACH in the EU in the last 12 years. So you can see just how important that actually is. And what happens in Europe will eventually roll out into the rest of the world, because you can bet your life the Europeans aren't going to sit around, spend all that money and not push this information out into the world. And they also take on board it's a legal requirement to be GHS compliant, which means the globally harmonized system all of the REACH material, regulation means that it's also got to be GHS compliant. So we spend a vast amount of time and money in that area. But cobalt is a critical metal. It's critical for the EU. It's defined as such. It's critical for the US. It's defined as such and strategically important. So that gives us a bit of a leverage in terms of industry. And there's a lot happening. There's the Canadian Chemical Management Program, the US EPA Water Assessment. Thankfully, they haven't picked on cobalt for that yet. And Asia REACH. There's China REACH. There's Korea REACH going on at the moment. We're providing a lot of data for companies in that area. So you can see it's hotting up a great deal. And we do recognize, we understand the hazardous profile for cobalt. What we tend to find is that regulators tend to over-regulate. And what we are arguing for is proportionality in that regulation. We recognize the cobalt salts we've always known they're hazardous substances. They're managed accordingly, but they don't need to be over-managed. They don't need to be managed to the extent that they may not be designed in modern materials. So that's more or less what keeps us going, because as I said at the beginning, our whole remit is on protecting market access for cobalt. We need to do that from a regulatory point of view, from a perception point of view, and from a practical, sustainable point of view. We need to demonstrate that cobalt is sustainable, that it's responsibly sourced, and that it can fit into the industrial environment safely and responsibly. And that's what keeps us awake day after day, and I hope that is appreciated by all the mining side, because as I said at the beginning, if we can't get it into the markets, there's no point in you guys digging a hole or trying to extract it. And I think that would say thank you very much indeed. It's a great pleasure to see you, and I hope that you found that interesting.
Thank you, David, and for keeping excellent time this morning. Perfect. And so we actually left us some time for questions, which means you're willing to take a few questions. And so if you'd like to ask a question, go to a mic, identify yourself, who you are, and your affiliation, please. There's a couple of mics. Could you just pop into the mic there, Jack?
Just to advise that I am not allowed to talk about anything to do with supply or price or things that would affect price. I don't want to get banged in the slammer yet.
Thanks, it was a brilliant presentation. Maybe your comment in terms of the recyclability of cobalt from superalloys. I think from batteries and a few other catalysts, I think it's pretty well recyclable. But a big portion of the cobalt goes into magnets and still goes into magnets and as superalloys. How much of that cobalt is actually recycled, and what's the ease of recycling, or the economics of recycling around superalloys?
Actually, it's an inverted question. Normally people ask it the other way around. They recognise that metallurgically you can recycle, but it's a bit more of a challenge from the battery side at the moment. We don't actually know, no one actually knows, but the figure that we've seen, which I think is pretty respectable, is that 68% of cobalt in metallurgical applications is recycled. Now, if you've got a gas turbine, you're not going to chuck it away. So the difficulty of measuring is that you're not going to recycle the cobalt, you're going to recycle the whole alloy. And that alloy will go back to the master alloy manufacturer to re-melt into a certified alloy. So the aeronautical companies and superalloy manufacturers will not tell you how much cobalt is in their alloy, because that's proprietary. But I think as a general rule of thumb, metallurgically, there's a lot of, it's a very high recycling rate. And certainly in superalloys, I'd reckon it's probably 90%. You're just not going to throw it away, apart from what's worn out and just worn in proceedings. But when you move into other areas, obviously you're not going to recycle dryers in paints or pigments and those sorts of things, but catalysts are largely recharged, recycled. Batteries, well, there will be. I mean, it will be an important part of what they do. It's just that right now there is a lot of battery recycling, but at the moment, and here's the rub: the new batteries in electric vehicles, for example, which is where the volume's going to be, they will last 8 to 10 years. They didn't expect that sort of lifetime. But what will happen at the end of a useful life in a car is that then it has a useful life as a stationary application. So you'll probably, let's say 8 to 10 years in a car, 8 to 10 years stationary. You don't need to recycle it for 20 years. And so there's going to be a lag before we get into large volumes of recycling for for batteries. And indeed, the car companies themselves are starting to look at designs for batteries which are amenable to recycling, because right now they're just battery packs. They've got to be shredded, chopped up, made into a mulch, and then you can selectively extract your energy metals from there. So that will come. There's no particular process that's dominating at the moment. Metallurgically, though, there's a large volume of recycling.
It's interesting that we mentioned that 10 years and then 20 years after stationary use, there's a lot of different numbers come out in the industry, and yet it's such a key thing, isn't it, as to the effect it's going to have on the supply and demand, that the timing of that is going to be very, very important. So thanks for that. And we've got time for another question. If you'd like to come to, yes, Mark, come to the mic, identify yourself and your affiliation, please.
Thanks again, David. It was a great presentation. I'm Mark Benz from MRB International. One of the things that I say in the mining press, so not the common press, and being utilized as an innuendo is new cobalt projects or cobalt-containing projects outside the DRC. And there's an innuendo often in the presentation that because we're outside the DRC, we're automatically responsible, and it almost seems to damn with faint praise everything that's going on in the DRC, yet it's coming from, from the project promotions. And I'm just wondering, is it just me, or do you see the same thing, and how do you deal with it?
Well, this is actually a perception issue as well, but you're right. I had it from one of my own members when we developed our responsible assessment framework. He was in the Midwest, and he said, "Well, it doesn't apply to me, does it? I buy cobalt oxide from a distributor." I said, "No, well, you're missing the point. Where does your distributor get it from? Look at our responsible assessment framework. There's a decision tree that shows you where to look for the potential risks." But you are correct, and this is where it's all changing. The OECD does not differentiate and discriminate like the NGOs, for example. The OECD wants to have all metals and minerals demonstrating that they are responsibly sourced, all of them. And even if you look at towards sustainable mining from the Mining Association of Canada, they didn't actually have the human rights element in there until recently, because we had a long chat with them about that, because we wanted to reference it in our own CIRAF, as we call it. But of course, it's Canada. It's got a human rights policy. It looks after people and this, that, and the other, but you actually have to demonstrate it, so it has to be in TSM. So it's demonstrating that you are sustainably and responsibly sourcing is the key thing. It's getting over that perception, so that anyone that produces anything, certainly in the metals and minerals space, will have to demonstrate it does that responsibly. Cobalt's been picked on at the moment for all sorts of the wrong reasons. It's very difficult. Well, in the industry, we don't need to have this industry responsible assessment. All our members are compliant in the way they should be. The trouble is the NGOs will not accept a corporate social responsibility statement or an ESG if it's produced by the company. They won't accept it. So we've developed something which takes it from out of their hands, and they have to report transparently over here. And we hope the NGOs will accept that. But you can imagine the problem we're in. Most cobalt is produced as a byproduct of copper and nickel mining. A small amount is produced by artisanal and small-scale mining. The artisanal and small-scale mining is largely subsistence. So if you try and demonize that, if you don't embrace it, then you stand a chance of pushing people into even darker corners when they can't even afford to put meals on their plate. Now, I know the artisanal and small-scale sector is very poorly regulated, perfectly legal, but very poorly regulated. So the key thing from my perspective is that our industry provides, let's say, some assistance in some form or fashion, certainly in the concessions, but outside that, civil society needs to be able to help invest on the ground so people can do what they do, but they do it safely or as best they can, because you can imagine from a practical point of view, the barrier for artisanal and small-scale mine for responsible sourcing is going to be down here. Whereas for large mining companies, it's going to be way, way up there, and they'll achieve it. So they need help. The whole thing needs to be embraced, not demonized. And there's a limit to what we can do as the cobalt industry. We don't represent artisanal and small-scale mining, but we've got to accept that it exists, and we built it into our CIRAF, the acceptance of local artisanal and small-scale mining. Because a lot of our members have illegal artisanal and small-scale mining on the concessions. How do you deal with that? It is problematic because you have security. How are you going to get people off? Are you physically going to manhandle them? That becomes very difficult. Are you going to call the local constabulary or the local military in DRC? Well, they'll probably come and shoot these people. It's a really difficult balance to get. And then, have I got a minute? Just a little story is that on one of my sessions there was a lot of, and if they can, they obviously have to get the people off. There's a safety issue and so on, get the people off, and they confiscate what they've been bagging and so on their land. Now, they came up with a wonderful idea that they'll take this bagged material, they know what it is, they can analyse it, put it into their process, and then the proceeds from that they can give to the local community. But they can't. Because they don't know how it was mined. Is it responsibly sourced? Was there conflict? Was there child labour? So they can't, so they have to bury it. And I think that's the tragedy of how these regulations affect the ability to try and have good community relations in the area. But it is a challenge. DRC, I'm sure, is the size of Western Europe, run by a very small and unfortunately corrupt government, and it's corrupt wherever its tentacles are, unfortunately, within the whole area. But how do you manage it? It's terribly difficult, and unfortunately it comes under the spotlight. But we had a very good presentation at our conference last week in Hong Kong from the DRC government, and they are looking to try and address these things much more effectively.
Okay, thank you very much. Let's thank David. Yes.